you need to ask other friend to do other transaction to send 3,000 back so that it becomes 2,000. So that means ledger means FN only. So ledger is some database which puts all the transactions one by one so that your account balance, similarly the other person's account balance, everything is maintained in a order. Okay. Now imagine who owns Bitcoin network? All the people who maintain node. So it is democratization. So blockchain brings democratization of money. So is there any central authority? Like there is no RBI or there is no US SEC who is regulating the money. So it's a peer-to-peer bank. Okay. Now when peer-to-peer is maintaining a bank, who will authenticate the transactions? The community, the other piece. So that means the ledger, the copy of that ledger is maintained across all the peers in the network. Okay, and if a transaction is to be validated between A and B, and assume there are 100 nodes in blockchain or Bitcoin. Okay, just assume initially. So A wants to do a transaction with B. And there are other 98 people who has copies of ledger in their individual nodes. So that is why it is called a distributed ledger, because the copy of same ledger is copied and maintained across the nodes. Now imagine I am an RBI person. Now let's come to the general typical scenario. Now I am an influential person. I could influence RBI or SEBI or some people to do some manipulation internally to that central server which is being maintained by RBI. Can I do that? Assume. Yes, I can just change. So I need to change data in one single server. I am done. My account balance is super high. Now imagine come to a blockchain scenario where if I were to have few more bitcoins than original, I need to manipulate data in 98 ledgers, or at least more than 51% of ledgers. So I need to manipulate more than 51% of all the network. And why will they come together? It's all peers. So why will they come together? That is one aspect. And second thing, now imagine I don't want to manipulate individuals who are maintaining the nodes because I don't know and they are spread across the globe. Then, if I have a supercomputer which is more powerful than 51% computing power of all the network, peer-to-peer network, yes, I can manipulate. But now imagine you need to spend around 25 lakhs or 25 crores and you need to do a small bank robbery which will get you only 1 crore. Will you do it? So why the hell you will access a supercomputer in order to get few bitcoins? So the logic is the amount you need or the amount you need to spend or the infrastructure you need to spend in order to crack a network, okay, is always higher than the amount of benefit you get out of manipulating the ledger. So that is a theory, that is concept of probably game theory which is used in blockchain. Okay. So typically, basically, so I hope you understood what blockchain in its core essence. So it's a distributed ledger technology. What is this distributed ledger? It is a ledger which has properties of create and read. That's it. Okay, and that ledger is maintained across the peers. So any transaction happening on one peer will automatically get broadcasted across the network. So that is how a distributed ledger is maintained across the network. Okay. So that is typically very basic definition of what blockchain is. Okay. Now suddenly what happened? If you look at Bitcoin, the number of transactions which gets validated in Bitcoin per second is hardly 7. 7 is a typical TPS of Bitcoin. Now imagine people started using Bitcoin as their currency. And do you know how much money is in world? $63 trillion is the total cash available on the earth. And $32 trillion is the amount which gets transacted across the globe. I'm talking about international transactions. $32 trillion is the amount. Almost half of the money gets circulated every day through 5 trillion transactions. And the present SWIFT system is able to process the Visa, MasterCard, the SWIFT system which is being, which got established in 1960. Still we are using that centralized system. Okay, now suddenly they are transacting millions of transactions per second. And today you are talking about, sorry, not millions, it is few lakhs of transactions per second is the capacity of centralized infrastructure or centralized banking system. And suddenly Bitcoin came and they are able to process how many? 7 transactions per second. Use that. That is one. And second thing, why only cash on blockchain? And then Italian Buterin, he is the one who created the next evolutionary step of blockchain, Ethereum. And what he decided is, money is only one value parameter which is transferred across people. Okay, but why not a asset? So probably, so that is where he came up with a smart contract concept, so that it's not just so almost like okay. So you can literally stop me once.
Yeah, but you can finish this and
No, once we have the
yeah, she's here, but you finish your thing and then.
Oh, okay. And so I'll quickly do. So then they came up with smart contracts, so that you can not only transfer money, you can transact an asset, something like a land record on blockchain. Now, let's say Andhra Pradesh government, they implemented blockchain on land records. And what are they doing? They are putting all that data onto blockchain so that it is immutable. Even government can't change the data. Okay. So when government pitched about Amaravati, the biggest challenge was people didn't accept putting the land records. Okay, they didn't believe in government that they will assign the lands. So what Chandrababu Naidu did is, he used blockchain as a backend technology and he has put land records on blockchain so that no one can change it. Okay, so that is how the second evolutionary step happened to blockchain through Ethereum. And Ethereum is doing only 14 transactions per second. Okay, then came private blockchains in order to increase the TPS. But in order to increase the transactions per second, they compromised on decentralization. Because private blockchains are not truly decentralized. And probably I'll set the context for the next speaker saying, rather than increasing the capability of TPS for public blockchains, world moved to private blockchains, which is a mix of blockchain and centralized architecture. Okay, so probably, at least if you take, what is that, Algorand, they are coming up with a pure proof of stake consensus protocol, so that public blockchain itself can do more transactions per second, so that you need not move to private blockchains just for the purpose of scalability. Okay, so with this I'll just conclude. Yeah, thank you.
Thank you. Alright, so hello. So we have Jing from Algorand. She is the chief scientist and head of research theory. She will be talking about Algorand, and if you have any questions, please speak in the mic so that she can also hear. Jing, are you ready?
Yeah.
Perfect. Over to you.
Great, thanks. Okay, hey everybody, this is Jing Chen from Algorand. I'm the chief scientist and the head of theory. So today it's great to share with you about in-depth discussion of what Algorand is and what we are doing and what is our roadmaps. I'm going to focus on our technology and recent development and what that means for building a decentralized economy. And so I'm remote, as you can tell. In order to save the internet bandwidth, I'm sharing slides rather than having my own face on the screen. But surely you can hear me, and then I'll be happy to answer questions when we finish, if people have questions. All right. Okay, great. Can you see the slides I'm sharing?
Yes.
Yes, you're audible.
Okay, cool. There seems to be some delay on the slide. Okay, perfect here. All right. So before diving into Algorand, let's first say something about why we are here in the blockchain domain. Because the blockchain is really a massive opportunity for building a
Jing,
bigger...
you are not audible. Just give us a minute, please.
Okay.
Sorry.
Suddenly went down.
Yeah, it suddenly went down. Okay, can you start again?
Hey, hello,
Yeah.
can you hear me?
Yes, yes, yeah.
Okay, I don't know where the audio got lost.
Just start from the starting. I think so the volume went down, so they could not hear you.
Oh, I see. Okay, that's fine. So as I said, I'm the chief scientist of Algorand, and I was the co-author of the Algorand consensus protocol. And right now I'm leading the effort of building Algorand's general purpose smart contract. So I'll say more about the consensus and our new features when we dive into the technical part. But before that, let's start with why we are here in the blockchain domain. Because the blockchain is bringing a massive opportunity for building a bigger and better economy globally. And why so? Indeed, on the internet right now, there are tons of information floating around, but those information's lack of organization and lack of trust, the value have barely been leveraged yet. And part of the reason is that there is a big erosion of trust, and the statistics have shown that among the people born after 2000, about 92% of them show distrust of big institutions like the government or financial institutions and big banks and so on. So they want a more decentralized, open space. And surprisingly, even though we all have access to, say, the internet, cell phone, online banks, e-commerce, there are still 2.2 billion people in the world who do not have access to, say, bank accounts or other fundamental financial services. And also, the current existing financial system is costing dearly of the whole world. And about 6% of the global GDP is actually attributed towards the transaction fees incurred by all kinds of financial transactions, like international wire transfers and so on. So that causes people a lot of money each year. And if we see all those downsides, we consider centralization is not a good answer to solving them. Because of what? For example, social media have shown a lot of information breaches, and people are losing trust for big companies controlling all their data. And internet providers, unfortunately, they are also growing into monopolies and having a small group of companies controlling almost all the communications among people. And instead, what about a decentralized solution? And what can we expect from a decentralized economy? First of all, the hope is that there will be more transparent prices so that monopoly is is less of a problem, and there will be low barriers for competition so that small businesses and individuals have an easier time to enter the market, rather than setting the financial market bar to be rather high only for experts. And then because of the distributed nature, the market will be more of a free market and have greater market efficiency to let the market regulate itself. Well, all those are great promises. And indeed, people expect a lot from the blockchain. We want inalterability. Every data that has been written into the blockchain will stay there permanently and cannot be changed. Blockchain is basically a append-only database. You can only add things to it, but you cannot change things once it is there. And that would have more of a transparency because all the data can be publicly accessed from the blockchain and therefore checked. And as a platform, it will facilitate trust and transactions among parties who sit remotely with each other, say in two sides of the world, and who have never seen each other. However, those people can actually enter transactions on the blockchain without ever need to meet each other or trust each other. Because of those promises, the applications that people have proposed that they want to build on the blockchain are almost unlimited. And we have seen a lot of successful cases already. So maybe this is a good time to say a little bit about what is a blockchain. The technical term is a distributed public ledger, which is a append-only database, and it's a sequence of transactions organized into blocks. Each block could contain many transactions. And the chains, if you know what a hash function is, the chains are done by including the previous block's hash into the content of the next block so that the previous block cannot be altered. And that is illustratively what we mean by a chain. What are the properties that we want from such a chain? We want four things. A, it's readable by all. By all, I do not mean only people in this room or people in a company. Here, all really mean all people on the internet can publicly access the data. And writable by all. We do not want the data to be controlled and added only by a small group of people. And anybody in the network could have an opportunity to point a finger and tell people, say, this would be the content of the next block. And then people would follow him. So small users would also have their own share. And tamper-proof, and that is achieved by having the blockchain hashed together with the hashes attached one by one, so that no content can be altered after written into the blockchain. Now, if you only look at those three properties, you may realize that they can be achieved by a well-designed centralized database. Have a centralized manager who take requests from users and do reading and writing accordingly. And if this manager is properly secured, then the database cannot be altered or tampered. However, a centralized management is not what we want and has been proven to be open to corruption, become the critical point of congestion, become a single point of failure, and etc. And because of that, the next property distinguishes blockchain from them, because blockchain does not have a centralized management. Everything is decentralized and the people participating into the blockchain manage themselves. So having such a distributed ledger is good for many things. If you think about it, we can do notarization because things cannot be altered. And we can order a chaotic situation and order transactions into an ordered sequence of data. And we can settle payments and issue cryptocurrencies. And there is a free virtual trusted party, which is a blockchain platform itself. Maybe one day we can even hope to have the blockchain help us curing the common code. Who knows? Now, those are really good things to have, and it's a dream infrastructure. Sounds like a dream infrastructure because there are so many advantages. The real question, of course, is how to implement it. That's getting technical. Now, building the chain is easy. As I said, you take the hash of the previous block, included in the content of the next block, then you have chained up everything together. The real difficulty is how to choose the next block. Who is responsible for choosing the next block? And how do people reach consensus about what the next block should be? Now, there are many proposals, solutions. If you look at the internet, probably there are 2,000 blockchain projects claiming they are working in this domain. However, let's make the implicit explicit. In the blockchain domain, the inspiration is still pretty far from technology. That we say there are a lot of promises, but when it gets to implementing and realizing those things, the technology, it's fair to say that we have gone a long way, but there is still a lot of things to be done. And even more so, that people find a lot of things to be so difficult that there is a famous blockchain trilemma, which claims that among all the good properties, the three important properties, decentralization, security, scalability, at most two of them can be achieved. Now, at the first glance, this may not sound that bad, but let me ask you, which of these properties are you willing to give up? Let's say we give up security. Well, blockchain is managing billions of US dollars in the financial applications today. And without security, nobody can have such a financial system up to the grabbing of malicious attackers. What about scalability? Well, right now we have many toy applications on the blockchain, but if the blockchain does not scale up to millions of users and billions of transactions, then we cannot hope to have it supporting real industrial level applications. It will only stay as toy examples. What about decentralization? Well, if we give up this fundamental core of blockchain, then we may as well go back to a centralized database system and delegate all the management to a small group of users. None of this is what we want to see, and Algorand does not want to give up any of this. So let me say that the blockchain trilemma is not acceptable. But fortunately, the good answer is that it's not true either. It's a claim people make to exaggerate the difficulties of achieving all three. But it's not a mathematically proved impossibility result. So it's really the alleged trilemma. And that leaves us hope. Indeed, when we try to solve those issues, people have to realize that the blockchains are not some buzzwords. They are really technical constructs. And in this domain, we need more technology to make things really work. And that is where Algorand becomes relevant. We often say that we are an alternative public blockchain because we are not a hard fork of any existing other blockchains. And we designed everything from scratch, learning lessons from the existing systems and rethinking about everything from the first principles rather than from heuristics. So we have mathematically proved our correctness and safety, and then based on this analysis, we are confident that our blockchain has been properly designed to achieve what we want to achieve. And really, Algorand is working to build technical innovations to be the infrastructure of a decentralized economy. Okay, so now let me say more about our team, who we are. We are a company based in Boston, in the US. Most of the people are based in Boston, including myself. So we're founded by Professor Silvio Micali, who is a professor at MIT and is the Turing Award winner of 2012 for his fundamental contributions to modern cryptography. If people work in cryptography, then you surely know that Silvio has laid down many of the primitives in the modern crypto world, such as encryption, signature, zero knowledge proofs, and many other things. And also we have a very successful business team. And then there is the Algorand Foundation, which is based in New York. We have Tao Rabin as a head of research. Yes, if you know who Tao is, she has been at IBM for more than 20 years, and she's really one of the leading figures in cryptography. And we're very happy that we not only moved her, but actually moved the whole crypto group to the Algorand Foundation. And then the head of operation of the foundation, Fang Fang, is joined Algorand in June. Before that, she was the chief operation officer of State Street in Asia, and she has been in the finance domain for many years. In the technical side, we have a team of top researchers and engineers. Myself working on the research side, and then we have UC working on the engineer side, and etc. So we have built a team about 50 people in the Boston office, with most of the people are researchers and engineers. And then we have also a very strong support, team on marketing and product and business development, etc. Okay, that is a brief introduction about our team. If anybody ever visits Boston, you're welcome to reach out and visit our office. That's what we call proof of life, just to see where we are and what the team is doing. Now let's dive into a more technical side, which is I'd like to tell you something about our core technology. Okay, so what are the popular prior approaches? You probably have heard about proof of work. That's what Bitcoin and Ethereum does. People use special purpose hardware to solve hash puzzles. And when they got the puzzle solution, they are able to generate a block and get rewarded. And then there are other solutions, which is based on proof of stake, and delegated proof stake and a bounded proof stake. Basically means that there will be a set of users, say 21 supernodes, that will participate in the consensus. And people would lock up a lot of their money in the system without touching, so that they can participate in the consensus. And if they are caught of doing wrong things, then the system will take their money away. So unfortunately, all of the designs have ended up with having the whole economy at the mercy of a small part. Say in proof of work systems in Bitcoin, about maybe 3 to 5 mining pools currently controls more than 90% of the mining power. And in other blockchain systems, there are, say, about 20 supernodes controlling the consensus, and so on. So in Algorand, we take a different approach. We call it the pure proof of stake because of the following, that there's no penalty needed. We do not take people's money away, even if they are caught doing wrong things, because we prove mathematically that even there are such malicious users, they will not be able to cause harm to the system. Therefore, their desire of doing wrong things has been reduced already. And we never ask people, we do not ask people to lock up your money in order to participate in the consensus, which is really friendly to small users, because we all know that, okay, there are big users who can put a lot of money aside without touching. But for small users who rely on all the money they have in the bank for daily lives, they cannot afford to lock up some money for a long time without touching that. So in Algorand, a user can spend your balance anytime you want. And it's whatever you haven't spent yet will serve as your stake in the system for the consensus. And of course, we need honest assumptions. Just like in proof of work, the assumption is that the computation power is controlled by the majority. The majority of the computation power is honest. In Algorand, the assumption is that the majority of the total balance, most of the money in the system is in honest hands. As long as that is the case, then security is guaranteed. So Algorand's approach is very simple at a very high level. Of course, there are all kinds of analysis that we need to do behind the scene to make sure that this really works. But at a very high level, the blockchain grows by having a sequence of ever-changing committees. And each committee is about 1,000 users, and the users are randomly and independently selected. And each selected user just need to do a minimum amount of work by sending a simple and very easy message. So let's dive into more in a more detailed fashion. I would like to describe the system as it's generating blocks in a very effortless way. And the blocks are just growing one by one. And the core is a Byzantine agreement. What do I mean by effortless and one by one? I mean the following. The blockchain will just start from the Genesis block. And then, just as light as a feather, the blocks are generated and added one after another. Sounds simple? Well, let's contrast it with what you would typically see in a Bitcoin network, in a proof work network. We talk about the blockchain all the time. But if you realize in Bitcoin, the data structure is never really a chain. It's really a tree, because there are many users simultaneously solving puzzles, and they may generate solutions without knowing about each other. Therefore, at each single time, there will be multiple branches in the blockchain. And it's only by waiting a long time and growing the longest chain, the hope is that the small branches will die out. And then a transaction appearing in B1, say, will be considered finalized enough when the blockchain reaches B5. But that does not happen in Algorand, that there is only a single chain ever being generated. So that provides immediate finality. There is no soft forks like the branches, and there is no proof work like the mining pools. And the gain here is also very exciting, that because there is no soft fork, every transaction that appears on the blockchain becomes immediate final. You do not need to wait for, say, hours in order to consider your transaction safe. it will never disappear. And you can immediately rely on it for future transactions. So that greatly improves the financial efficiency of the system. And then because there is no proof of work, every single user can easily participate in the system. You do not need to buy special purpose hardware. I don't need to join a mining pool. All you need is a laptop. Say I have a laptop and I use it to run Algorand node all the time, from time to time. And I sometimes even run it in a virtual machine, and that's no problem. So participation is pretty easy and lightweighted. Okay, now we get into Byzantine agreement, which is a classic concept in computer science. And they are communication protocols for distributed parties to reach consensus when the majority is honest. Now, at a very high and superficial level, it may look like this is simply exactly what we need for running a blockchain. Because we could just ask all the users in the blockchain system to participate in a Byzantine agreement and reach consensus on what the next block should be. However, that is not quite the case in reality because of a few things. First of all, classic Byzantine agreements are very slow. And by very slow, I mean that, okay, they have been proven to be polynomial time. If you know, polynomial time is considered efficient in computer algorithms already. But on the blockchain, when we are dealing with millions of users, being say quadratic time is already not acceptable. So we need super fast Byzantine agreement. An even more serious issue is that a classic Byzantine agreement is designed in a more enclosed environment where the set of players are fixed and known in advance. Neither of this is true on the internet. There are Sybil attacks that we do not know how many public keys a single user can control, and we do not know which keys belong to the same users. So because of that, we cannot directly use existing Byzantine agreement. Instead, we designed our own super fast Byzantine agreement that scales on a planetary scale and with very high efficiency. And there are many other technologies we added to the Byzantine protocol in order to make it actually work. And I'm not going to tell you all the technical details, but in the next slide, I'd like to introduce you, in the next two slides actually, I'd like to introduce you another fundamental idea in Algorand blockchain besides the Byzantine agreement itself. So before that, let's first look at what is the adversary model we have in analyzing our protocol. So this is the adversary we're trying to protect against. Let's just read through the list. We allow the adversary to immediately corrupt any player. And we have the adversary who is able to perfectly control and coordinate all the bad users. And the adversary not just can attack the protocol, but can also attack the network, meaning that maybe he can bomb the data centers and cut cross-continental cables so that he can isolate the network and partition it. But there's one thing we do not allow. The adversary cannot forge signatures, or in general, it cannot break the basic cryptography primitives. Because cryptography is really the foundation of internet communication, and without having modern cryptography, we can't say anything about the security. So this is what we do to deal with such an adversary. We call it cryptographic self-selection. The key here is the word self. Remember that our blockchain generates blocks by having a committee that is ever changing. And this is how the committee gets selected. Nobody dictates the committee, because then that would be centralization. Instead, each user secretly selects himself And he does so by doing a secret lottery of his own. And in such a lottery, strangely, he cannot cheat if he is not selected, but he can prove that he is selected. Because a lottery, because it's really similar to a physical lottery system. A lot of people have seen lottery machines on streets and in various places. And people buy lottery tickets. And with a lottery ticket, if this person wins, he can show up and claim his reward, showing with the tickets. And when the ticket is well designed, a person cannot fake up a ticket if he does not win. However, what's the difference? The physical lottery system has lottery tickets printed in a centralized way and then distributed to various places to sell. Do we allow people to print lottery tickets at home by themselves? Well, we don't, because we can't. If a person is able to print lottery tickets at home, he could print not just one, but maybe he ended up printing 1,000 lottery tickets. He would print one and see, oh, this one does not win, so let me print another. And I can print another and another until I got a winning ticket. And then I show up to claim my reward and burn the other 999 unwinning tickets, and nobody would know that. So in the physical world, we do not allow people to print their own lottery tickets. Strangely, in the digital world, with the help of cryptography, we allow people to do exactly that. And we allow them to do it in a deterministic way, in a unique way, so that a person, no matter how many times he tries, there is only a single ticket he can print, so that he really cannot cheat. And the benefit of this are manifold. First of all, because of the self-selection, there's no need for people to communicate with each other about who is selected. And that helps both the system efficiency and improve the system security. Because there is no communication, the adversary does not know who to corrupt before seeing their messages. And after seeing their messages, the user's job is done now. And it does not help the adversary to corrupt such a user. And for the next step, a new committee is reselected, again randomly and independently, so that the adversary does not gain any advantage corrupting existing committee members. Okay, so just to test whether you have gotten the key ideas. So who selects the committee? The committee selects themselves. Each committee member secretly selects himself. And there is the self-lottery, and he propagates his winning proof and then plays the Byzantine agreement. And importantly, the probability of winning is proportional to his total money in the system. It's not about how much money you can lock up, it's really about how much money you have in total. So this is definitely decentralized. There's no dictator. And it's very scalable because the communication costs and computation costs are all reduced to a minimum level. And then it's secure because the committee selection is hidden and the adversary does not know who to corrupt before seeing their messages. And yes, indeed, we have really solved the trilemma. And Algorand provides the security guarantee at approvable fashion, which is very rigorous in mathematics. Okay, so this is a little bit of what I want to say about our core technology. We're not going to dive into more technical details, just to wrap up and saying that we have a market, a blockchain market that is full of promise, and Algorand steps out because we really deliver credibility, that we have proved the guarantee and implementation of the protocol and the entire system. Okay, so stepping out, zooming out a bit from the the deep down technical details. Let me tell you something about what we have built in terms of a real system since the beginning of the company. We set up the company in January of 2018, so it's a bit more than 2 years now. And we have done several years of work even before that to develop the protocol. So last summer, we finished a round of fundraising and successfully raised $62 million from a group of global investment companies, including both new crypto companies and classic financial companies. And the distribution is really global from all kinds of many countries.
Mm-hmm.
So even from the fundraising side, we already have a very decentralized approach. And in the technology, in the engineering side, the deployment has gone through 3 major stages. At the beginning, we have an internal DevNet, which we still have for internal use only, and to test out all kinds of ideas we have and build new features. And then we develop the testnet, which is already open to the public. It's not a mainnet, means that the tokens on the testnet do not have any value, and we may restart the testnet and change things in the testnet when we want to try out new features. But the testnet is also a stable environment for our partners and developers to try out their own applications. And for people who want to build new things on the mainnet, it's always a good idea to first try out in testnet and have it running there stably for a while before bringing it to the mainnet. And then finally, last summer, that's the summer of 2019. Yeah, actually the fundraising was done in the summer of 2018. Always forget we are already in 2020. Sorry. And last summer is June 2019, and that's when we launched the mainnet. That's a very big milestone, and we set out the Genesis block, set up the network, and ever since the mainnet has been running smoothly without any glitch, and it's generating block about 4.5 seconds per block. So it's a permissionless and public blockchain that anybody is free to send up and join the network. And as a decentralized blockchain, we know it's important to be open source so that anybody can look at the code and see what we have been doing. So we have fully open sourced our entire code base, also last year in June. So the entire thing is on GitHub. Everybody is welcome to take a look. This includes both the consensus protocol and SDKs and cryptography primitives, signatures, and so on. So there are many components there. Everything is there already, actually. And then another important milestone is that before we make the code open source, we have several third parties audited the code so that it really reaches the industry level of code quality and the documentation. We got very good feedbacks from the auditors there. And here is what I want to share with you. The developer website, the developer community. I don't know how many people in the audience are developers, but if you're interested in coding, you should definitely explore this website. Here you can find all the tutorials, examples about how to set up a node, how to build your own wallet, how to build your own asset, and then there are all kinds of SDKs. Also, you can find the Algo Explorer to track on the blockchain. And this is a early picture of the node map. I haven't updated this picture for a while. We right now have several hundreds of nodes in the system, and they are really distributed all over the places. Algo Explorer, yeah, this is what I talked about a minute ago. Here you can see all kinds of information about what is the latest block, how many transactions are there. You can also click into it and see the details of each transaction and search the specific public keys. And that's a place to play around and get familiar with the system. And then, as I mentioned, we have provided SDKs for several languages already, and we're still adding to the toolbox gradually. For example, we have Python, we have Go, Java, and JavaScript. I think C#, no, not C#. It is C#. We have a C# SDK under development, and other SDKs coming too. So we let people build in whatever language you want in order to talk to the blockchain. And yeah, this is the bug bounty program. We also launched it before the mainnet launch. So if you find a bug in the system, instead of posting it on Twitter, please post it here. And we'll be happy to hear from you. And this is an interesting piece I want to share with you, which is how efficient our blockchain is. We keep on saying that we do not do mining and we do not need mining pools. And I typically use a laptop to run a node. But a colleague of mine had pushed it to a limit and built an Algorand node on a Raspberry Pi, which is really, if you do not know what it is, it's really a low-end hardware. Probably costs about $100, for example. So that shows really how lightweighted the consensus protocol is. And then this is, this is my work. This is another approach we explored to further verify the correctness of the blockchain. Besides our pen and pencil proofs, we have papers already published at major journals and conferences. But now we have also explored the formal methods to build a model of the Algorand consensus protocol in Coq and formally check that the safety properties of the protocol that we want to achieve. So that is our work with our partner, Runtime Verification. And we are very happy that they have done such a thorough job. All right, in terms of transparency, we said that blockchain is for transparency. And we take this seriously. So that's why the company has publicized our own wallet addresses so that everybody can see what are the tokens, see the tokens, and how the tokens have been used for. So this is really our effort and commitment to transparency. And then there have already been many teams building on Algorand. And this list is growing every week. For example, this bring stablecoin to Algorand that is coming very, very soon, if not next week. Well, stay tuned about that. And then we have become a member of the International Swaps and Derivatives Association. We are the only public blockchain member of ISTA. ISTA is really driving financial standards for many financial trades. And then we have people say World Chess Association. They plan to do a hybrid hybrid IPO on Algorand, which means that they are going to issue part of the security in a traditional exchange. And then they're going to issue part of that on Algorand blockchain as tokens. And more are coming. And if you want to know the most recent update about the business side, what Algorand has been doing and with our partners, this is where you can find all the most recent news. Say, for example, we have partners who are building online trust applications We actually have partners building global air quality monitoring applications on our blockchain, etc. Okay, so that is about a very quick overview about our business and engineering development. I think this is a good time that we have done some non-technical stuff, and now I'd like to bring you back to a little bit of a technical stuff, because I really want to report to you our V2 upgrade and our layer 1 strategy. So after the mainnet launch, we have been busy developing new features in the blockchain. And in November 2019, we have upgraded the platform to V2, and we have added several new features to it that would facilitate financial applications and allow people to do way more interesting things than just transferring tokens. So this is what I want to tell you a bit about. So there are 3 main features in V2, and which is already available now in the network. We allow anybody to issue your own assets in layer 1. We call it standard assets. And we support atomic transactions, which means that a group of transactions can be simultaneously cleared altogether. I'm going to say more in a minute. And then we support a form of Algorand smart contracts, also in layer 1 directly. Why I keep on emphasizing layer 1? Because most of blockchains support only very simple payments at layer 1. For example, in Ethereum, layer 1 is only about transferring Ethers, and any other applications and functionalities have to be done by layer 2 smart contracts. But by building features directly into layer 1, what we gain are both efficiency and security. So all these features would have the same clearing speed as how fast we generate a block, and all of them will have the same security level as the Algorand blockchain itself. Of course, all of them have to sit in the blockchain's critical path. And that is why we have been very thoughtful about which features to add to layer 1. Because we want to make the blockchain usable, more usable, without sacrificing the speed. And we have chosen those 3 in this version. So let me say more about it. So in the standard assets, we provide all kinds of templates for user to issue your own assets, tokens, cryptocurrencies. So any user can create such a new asset. And you decide what is the rules you want to impose on your asset or tokens. You may set a potential supply as a creation. You may decide the token can be freezable or cannot be freezable. Some financial companies want the token to be freezable because they represent some security, some financial options. Some other users may not want the token to be freezable, so that they can serve as commitments to other users that the creator does not have full control of the tokens. The token creator is the initial manager, and he can also transfer the managership to somebody else he chooses at a future time. And the manager could probably, increase the circulating supply, freeze the token if the token is freezable, destroy tokens if no tokens are circulating, and as I said, transfer the management right to another user, and so on and so forth. It's important to realize that those tokens are not layer 2 tokens controlled by smart contracts. They're really at the same level as the Argo, which is a native token of the blockchain, that any user can transfer those tokens just like how you would transfer Argos. And as long as the blockchain is secure, those tokens are secure. So that's a big benefit for having it in layer 1. Now, atomic transactions. This is something I'm really excited about. We thought about this for a long time, and we realized this is a critical feature that we want to support, which is simple. We want multiple transactions to be grouped together so that either all the transactions occur on the blockchain and get cleared, or none of them would do. So that's what we mean by atomic. And this can be used in many applications. Think about a trade among two parties, say. Party A pays Party B certain amount of tokens in exchange for Party B transferring back certain amount of another token. Now, there is always a problem of who acts first, because the person who acts next always have the option of shirk out, that ends the trade without suffering any consequence. And the first user would risk of losing his tokens. And this is really fundamental issue in today's financial systems. And that's why we see a lot of, third-party authentication, custodial, auditors, legal terms to be called in order to make sure that a trade is carried out in an atomic way. But in our blockchain, we do not need any of those third-party services, because the blockchain would simply consider those two transactions, those two transfers, as an atomic group. If one of them does not clear, then the other will not happen either. So people do not really need to worry about who acts first, and the first actor does not risk of losing anything. And a side effect of such atomic transactions is that we support atomic swaps without using hash time locks. If you know what hash time lock is, that's say some user has to lock up his token in an escrow account and without touching it for a while, and then the next user would unlock it and by making a proper transfer to the first user, and etc. So that causes a lot of delay in the transactions, and still it's not risk-free. And sometimes people still end up losing money if the blockchain is attacked. So we avoid all that by having a single atomic transaction group to deal with atomic swaps. And some applications, there are plenty of applications, bilateral exchange, even circular trades can be done in an atomic way. Say, Alice pays Bob, if Bob pays Charlie, and if Charlie pays Alice. And there can be arbitrary number of users paying each other. And they can pay each other with any type of assets in layer 1. And this can be done to facilitate decentralized exchange and having internal units of accounting like credits, rewards, and so on. And payments to multiple recipients, like a company may want to pay his employee, and the employee may want the salary end up in 3 bank accounts, for example. So all of this can be easily handled by a single atomic transaction. And then a third feature is another thing that we have been really thinking about it, which is having a very simple logic in layer 1 directly to deal with certain predicates about the balances. You may have seen scenarios where transfers may happen with conditions, and those conditions can be represented now in a very simple language. We call it TEAL, transaction evaluation authentication language. Very basic language, and has only Boolean outputs with 30 basic instructions. It's in some way it's similar to Bitcoin script, and we allow transactions, TEAL control transactions, where users can issue and can authorize transactions by not by generating digital signatures, but by providing a TEAL script using the logic to drive the transaction Is there anything wrong with the presentation?
Yeah, just a minute. I'm just starting the projector again. There was a change in the electricity, so that's why the projector got switched off.
Okay. Do I need to go back and rewind from somewhere, or we're good?
Yeah, same slide only. This happened on the same slide. So.
Okay. About the smart contract in layer 1.
Yes. Yeah.
Okay. Okay. That's good.
Yes.
Okay. Yeah. Okay. All I'm saying is that, well, you didn't miss much. What I'm saying is that we now support a very simple logic in layer 1 to govern the clearance of transactions. So Q is a very simple script language with 30 basic instructions. Somehow, in some ways, it's similar to Bitcoin script. It does not provide any side effect. It only returns Boolean values, and the Boolean values are used to govern the transfers. For example, we support Q-controlled transactions, which means that a user may authenticate a transfer of his money, not by providing a digital signature, but by providing a Q script. And we also have Q-controlled accounts, which are really accounts that do not have a secret key. Those accounts have a Q script associated with it. And it's a Q script that governs how this account can be accessed. In some way, it's similar to smart contracts in general, except that the Q language is very simple and only has Boolean option, only have Boolean outputs. I want to emphasize that those executions do not have side effects on the blockchain. This is critical because that avoids the state space explosion like in other blockchains. That is really a Boolean output only. So we do not need to worry about storing the side effects. And that is the next stage when we get into the general purpose smart contract, as I will show you next. So that's Q. So right now we have very simple logic on the blockchain to do more sophisticated things. What can we do? For example, people can use a Q script to write post and sale transactions. A user posts his item on the blockchain, and then he can go on vacation without monitoring. And anybody who wants to take the post and buy it would just issue transfers to the seller and with the Q script, and automatically the transaction will be cleared. And we can have loans, and collaterals can be kept in a escrow account controlled by a Q script, so that if the borrower fails the payments, then the lender can take the escrow and finish the loan. And then we can do crowdfunding. If somebody set up a project and has a goal, and anybody can send money to it via the Q script, and then the script controls when the funding finishes and how to transfer the final money. And there also you can use the standard assets combined with the Q script to deal with accredit-only transactions. So these are not the day-to-day transfers. Those are really required by several financial entities because they trade real assets and other financial products, and they really want to have a way to serve accredit-only users. And the standard assets will provide them with such a tool. Okay, all in all, the 3 features introduced in V2 really opened up the possibilities about what people can do on the Algorand blockchain. And since then, we have seen a lot of projects setting up to build their applications on the blockchain. And we are expecting more to come. And if people in the audience are interested in building anything, you should start looking into the developer website. Okay, this is almost the end of my talk, and I would just like to use the next few minutes to say briefly about the forthcoming technologies we are building. So the first thing, hello? Is the electricity gone?
Jing, are you there?
Yes, I'm here.
Yeah, internet also.
Can you still see the slides? Well, it's good that we are actually reaching the end of the
Jing,
of my talk.
sorry.
Yeah.
Jing, actually we lost you in between. So can you start again, because there was some the light had gone, so everything shut down. So can you start again from the starting?
Last slide.
Do you want me to sign out and redial into Zoom?
From this particular slide only, from general purpose smart contracts.
Oh, I see. I got what you were saying. Yeah, I don't think people missed anything. We're reaching the end of the talk, and I just want to take this one single slide to tell you a little bit about the forthcoming technologies. The first is really the general purpose smart contract, which I have been working on. And that will be a different solution. It will not be in layer 1. Because in layer 1, as I said, we cannot put a lot of things in a critical path. And we do not want to slow down the blockchain. Therefore, the general purpose smart contract will be a layer 2 solution, but it will be a very different solution from the existing solutions that you have seen. Cold chain and token bridges are our solution for interconnectability, to bring tokens in other blockchain and map them into Algorand. And for other users to set up their own small environment as cold chains and connect to Algorand main chain, if they want a more enclosed and privacy-oriented and permissioned system, they can use cold chains. And then we are developing privacy-oriented solutions to help better protect people's privacy in the blockchain domain, etc., etc. So there are many things that we are developing in the research side, and stay tuned about it. All right, this is really the last slide, and I really want to say that we have opened up the space for building a decentralized economy by providing an infrastructure. And I want to invite people to join us. You can follow us on the social medias, and if you search at Algorand, that will be very, very likely to be us. I cannot promise you there are no scams. Sometimes there are. But if you see scams, please tell us. But most time you will see our official channel. And then we have the community website and the developer forum website. You can join us by being an ambassador and contributing to the developer community. Okay, well, finally, developing new technology is not only about hard working. Very often it's about having fun too. So if you look at the Algorand blockchain, if you can go back to find the Genesis block, when we set out the Genesis block, we hide a word puzzle inside it. Take a look and see how you would solve it. All right, let's hope to hear from you, and thank you.
Thank you, Jane. There are a few questions that they have, so I'm handing over the mic to the audience for the questions.
Sure.
Hi, Jing. Hope you can hear me.
Hello. Yes.
Yeah. So I have quite a couple of questions, but maybe I'll start off with the simple one. So what's the block size in Algorand?
The current block size is 1 megabyte.
1?
megabytes.
1 megabyte. Okay. So how many transactions can happen in that 1 megabyte?
It depends on how big a transaction is. We allow up to 1 kilobytes in one transaction's payload because a transaction has two parts. One is the main part, which is, you know, who is the sender, who is the receiver, and how many tokens are being transferred. This part only takes a few bytes. And then we give up to 1 kilobyte per transaction as a notes field. Means that people can write all kinds of notes in this domain. Say somebody may want to leave a note about what this transaction is about, etc. If the transactions only have the payload and not having the notes field, then the blockchain has no problem of having something like 5,000 transactions. And of course, if each transaction has 1 kilobyte of notes field, then you can do the mathematics, and then a blockchain will fill about 1,000 transactions.
Okay. Also, I noticed that Algorand sort of promises that the tokens held by Algorand will never cross more than 49% of the vote. But then isn't that also, I mean, that way you can swing the vote anyway. For example, if 2% of the people are voting in a particular way, you can make sure that, you know, that becomes the voted block. Correct? So how does that
right. Of course, I think that's a very legit question. That is about what is a path toward decentralization. So our vision is that decentralization is a long way, and we will start from the beginning and gradually disseminate the token to the community. That is why I took a point in my talk and want to tell people that we have publicized all our wallet addresses so that everybody can check what percentage of Algorand's tokens are voting and what percentage are not voting. So you will realize probably our voting percentage is not that high. I do not have the concrete number here, but you can check, everybody can check. So that is our commitment to being transparent. And then gradually in next few years, we will gradually distribute the tokens via secondary markets, giving to developer incentives and so on in various ways.
All right. If you don't mind, I mean, I have a few more questions.
Of course.
Yeah, so what do you mean by no side effects in the state space explosion when you use the teal scripts?
Oh yeah, so that is, if you are familiar with Ethereum blockchain, Ethereum smart contracts have all the state space to be stored by the entire blockchain. And people, when they create contracts, create tokens, so all those contracts are stored, and the contracts would have their internal variables, and those variables take up spaces as well. So the Ethereum blockchain have the state space explosion, and I think their entire data structure has reached something like terabytes. So it becomes very difficult for a single, like a small user to store the entire smart contract database. So the teal script currently do not have side effects, means that they do not cause extra storage space to be created. Like there is no smart contract internal variables. It does not cause it does not cause state transition in the blockchain either. All teal does is to have a predicate that evaluates on the current blockchain state and output a Boolean true or false. That's all it does. And the Boolean true or false will be used by the blockchain to validate the transactions containing the script. So it does not read or write the data. It reads the database, but it never writes in the database. Does not create extra storage. Therefore, does not cause the state space to grow at all.
One more question I had is about, if you look at Bitcoin, which has the scripting language, ultimately it is having a UTXO model, right? So what
Correct.
model is used here? Is it a UTX or is it state or is it hybrid or how does it work?
I didn't quite get it. What was the question?
I mean, if you look at Bitcoin, for example, it uses a UTXO model,
Yes.
and Ethereum uses a state transition model.
Yes.
So how does Algorand, manage this? How the money is flowing through?
Okay, got you. Algorand use account balance model like in Ethereum. So UTXO model has all these accounts being part of the blockchain itself. Right? Each UTXO will be spent and split into multiple UTXOs in a transaction, or multiple UTXOs will be spent into one UTXO. Ethereum instead, the account balance model is such that the balances do not appear in the blockchain, but is a side database that will be derived from the blockchain. So there will be a database storing address number 1, balance number 1, address number 2, balance number 2, and people would transfer tokens among the account, much like how we transfer among bank accounts, right? Instead of specifying entirely this account spent to another account, you specify I want to transfer 5 ethers from one account to another. We go the same way as Ethereum in this sense. You can transfer any amount of Argos from a account to another account. Of course, there are various takes about between UTXO and balance based accounts. Our take is that we find this way more flexible and intuitive for people to handle. Also, without having the balances on the blockchain itself does not deal with a large data structure of storing all the UTXOs. So basically, flexibility and efficiency are the major considerations here for us.
One last question from me. So if you look at Bitcoin or Ethereum addresses, they're typically very cryptic. It's a hexadecimal string. So has Algorand done anything to make the addresses more readable or more uniquely identifiable?
Hasn't provided anything to do what?
If you look at Ethereum addresses, for example, they're hexadecimal strings.
Okay.
Yeah. So are Algorand addresses also equally difficult to read, or are they human readable in any way?
Difficult to read of what, the blockchain structure or the balance structure?
Address, the account address, for example, 0x.
Account address. I think I got what you're asking. Let me try. We'll see whether that is what your question is, because I still can't quite hear you. So we do use the byte string encoding of addresses. So which means that you cannot take a email or a phrase and use that as the account address. So account address is a byte string. 128. I forgot how long it is. About 32 bytes, I believe. And then there are checksums. So in total, maybe 50 bytes, around 50 bytes. If people want to track the addresses, as I mentioned earlier, we provide the Argo Explorer, which is a website that can be accessed from the developer website. If you look into the Argo Explorer, you can track all the blocks generated so far and all the transactions in it. And then if you click into a particular account, you can also search all the transactions associated with this account. That's how we deal with addresses. Does that answer your question?
Yeah, I guess. Yeah, I'm done with my question. Thanks a lot for the clarification.
Hi Jing, this is Aravind.
Hello.
Yeah, so I have 3 questions. One is, if you look at mining pools, you mentioned you solved the trilemma. So how do you take care that proof of stake doesn't interfere with mining pools? So what is the care?
How do we
Is
take
that
what?
randomness you are bringing in?
I
Can you
couldn't
get my question?
quite hear you.
Hello.
Yes, yes. Can you say that again? Your voice disappeared towards the end.
Oh, okay, so I'll repeat my question. See, you said the trilemma is solved, right?
Yes.
So when you say that, one of the biggest challenge everyone says regarding proof of stake is if mining pools comes up so huge that suddenly majority of the nodes are maintained by a pool. Okay.
Yes.
Even though you randomly choose or randomly come up with circles or committees, so how do you solve that? Concentration of more algos with few mining pools. How do you solve that?
Okay, very good question. Thanks. I finally got what you are asking. So that's a very deep technical question, and so we do the cryptographic self-selection by making the selection probability to be directly proportional to the user stakes. So when I say directly proportional, means what? Means that if this user has 1,000 tokens, and the system in total has 1,000,000 tokens. These 1,000 tokens will be selected in exactly the same way, whether they are in the same account or they are split into 1,000 accounts with 1 algo each. The selection probability for each algo is the same. So in other words, it's not a user who is getting selected, it's a token that is getting selected, and then the owner of the token will do the job. So if a user controls these 1,000 tokens, having them in 1,000 accounts will just function exactly the same as having them in a single account. Therefore, there is no need for him to overly concentrate.
Okay. So, and see, there are many scaling scenarios like Casper, sharding, and side chains. So, so how do you see pure POS will be able to come up more than all these things, all these techniques?
I think you're asking about extensions, further scaling up, right? Sharding and side chains. They sort of solve different problems. Sharding is more about further expanding the blockchain's capability. And sidechain is really a good thing to deal with interconnectability. We currently do not plan to implement sharding, even though we have been discussing sharding as a potential future solution. From the technology side, we do not see it's necessary to introduce sharding right now in the Algorand blockchain because the blockchain itself is already fast enough. And if later the blockchain developed into a critical stage where it is becoming congested, then that would be a good time point to consider solutions like sharding. Then in terms of interconnectability, we call it co-chains. So co-chains are token bridges, are pretty much our version of, if you call it side chains. We just do not want to call it side chains because that sounds like that side chain is not as important. So the co-chains would allow people to set up their own consensus environment and having their own state committed to Algorand. And token bridges will help people to map tokens from other blockchains onto the Algorand blockchain and then enjoy the higher transaction speed and finality on Algorand. So those are our current solutions for interconnectability.
Okay, so one last question. So Ethereum came up with their own private blockchain equivalent. So what do you think about that, and what's your take on?
Did you say private blockchain equivalent?
What?
Huh?
Oh, okay. So see, Ethereum came up with enterprise blockchain, private blockchain for Ethereum as well, right? So,
Mm-hmm.
what's your take on Algorand's strategy to capture the enterprise blockchain space?
Good question. Yeah, this is more on the BD perspective. So let me say that the main Algorand blockchain is committed to be public and permissionless so that everybody can access. It is actually pretty easy to take our code and set up your own private environment. We actually have tutorials on our website about how to do that. It's open source and under, I forgot which license. So as long as you follow those licenses, there's nothing wrong with you take the code and set up your own private environment if you want. But if you want to be interconnecting with other blockchains, then my recommendation would be use a co-chain. Co-chain is meant to be permissioned and enterprise. But the co-chain also have the feature that it is connected to Algorand blockchain so that it can interact with other co-chains. For example, maybe different industries or companies, maybe Morgan Stanley want to have its own co-chain that is permissioned and enclosed. And another bank, Bank of America, may want to have a co-chain for its own. But Bank of America and Morgan Stanley want to talk to each other and trade assets. And if they use co-chain, then they both connect to Algorand main chain and they can trade via the main chain. Bottom line is that if people start with a public blockchain, it is easy to scale it down and use it in an enclosed environment. But if you start with something that is meant to be enclosed, then it will be pretty difficult to scale it up and become open. So I actually didn't know that Ethereum has its own private enterprise solution. I think that's good. Ethereum itself is a public solution. And then if they want to build a permission solution, that could be easy for them. And this is the same thing for Algorand.
So co-chain has its own ledger, I mean separate ledger, or that talks to the main net, I mean the public net.
You're asking about co-chains?
Yeah, I mean the co-chain, will it have a separate ledger, or even all transactions happening on co-chain gets committed on mainnet?
They have their own ledger. And even if they want, they can even have their own committees running their own consensus.
Oh, okay.
But they will have states committed to the main chain and trade on the main chain.
Oh, okay. So thank you so much.
Welcome. You're welcome.
Anyone else have a question? All right, okay, Jing, that's it. Thank you.
Thank you. Thanks everybody for coming.
Thank you.
Bye.
Bye.